I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand and also do chemistry in your everyday life.
Okay, Jam, I gave you an assignment for an experiment this morning.
Yes, you did.
Can you tell me about it?
Yes, you gave me the instructions and I decided just to do whatever I wanted and I just did my own thing.
And what was that? What did you do that was whatever you wanted?
So you told me to get some household items.
Right.
Honey.
Mm-hmm.
Corn syrup, which I didn't have exactly that, but I had maple flavored syrup, which is corn syrup with maple flavoring in it.
Right.
Dish soap.
Mm-hmm.
Vegetable oil.
Mm-hmm.
Water and rubbing alcohol.
Right.
And then you told me to put, this is also the things that you can do at home while you're following along. You told me to put those things in a clear container of some kind, glass or a bottle with the top cut off, and to put a layer of those substances in that order.
Right.
From beginning to end in that container and see what happened. And then you'd also told me to drop some objects in there.
That's right, I did.
So that is what I did.
Okay, so when you poured those things in on top of each other, what happened?
So the honey was the first one I poured in, and it stayed at the bottom, which kind of made sense. I thought that might happen with it being so thick. And then the maple syrup, they were slightly different brown colors, but I could tell that they stayed separated and that the corn syrup, maple syrup was on top of it. And the dish soap I had, unfortunately, was orange. So it was a little similar to the color of the other stuff.
It'd be nice if it was blue, like Dawn dish soap or whatever, but that's okay.
We just finished a yellow thing of dish soap, so that would have been perfect if I still had some of that. But I can still tell the difference, and hope that you guys in the video can see a little bit of the difference too. And that stayed on top of that one. And then when I did the vegetable oil, it also went on top. So far, everything was staying on top. And then the water, I had put a little bit of blue food coloring in to make it a little bit easier to see. And it went under the oil. And started mingling with the soap a little bit. At first, there were some suds and stuff, actually. So it kind of got a little muddled there. But I didn't, obviously agitate it at all. I tried to pour it really gently. And it ended up settling out.
Nice.
And then the alcohol was one of the harder ones to see, I think. I think it's mostly stayed on top. But I couldn't fully tell.
Because it was clear?
Because it was clear. I think it actually ended up mixing with the water a little bit. If some of it got below the oil, I think it mixed with the water.
Okay, so I think I maybe... One of us mixed some stuff up. I think the water was supposed to go in before the vegetable oil. But it's not the end of the world.
Uh-oh.
It doesn't really matter because what's fun about science is you get to see. Did I send it in that order?
Yeah, I actually put the things in the order. Like I put the bottles or whatever in the order. But somehow, at some point, maybe when I added the food coloring to that water, it got out of order. Like I had them lined up.
That's okay because it actually still shows the property that I wanted to show.
Nice.
And it demonstrates how you can kind of mix this experiment, mix it up literally and figuratively.
Yeah.
So this experiment is all about density. Density, I'm sure most people know, but it's mass per volume. So usually we do grams per milliliter or something along those lines. So is it how heavy is this based on how much you have of the liquid? And I gave you the list in an order of increasing density. So you put the most dense on the bottom and the least dense on top, and it forms this nice layer. If you have the light corn syrup that's clear, it looks really cool.
Yeah.
With the brown from the honey and the clear corn syrup and then a different color dish soap and then water and vegetable oil and rubbing alcohol. And you can put food coloring in the water or the rubbing alcohol or both.
Yeah, you guys could learn from my experience of having things that looked pretty similar in color. If you do have the opportunity to not have it be like that, then you can avoid that.
So you can pour them in and the liquids will sit one on top of the other, which I think for us adults is pretty intuitive. You know that if you put water and oil together, they're not going to mix and one's going to sit on top of the other. But kids don't know that. Kids don't cook or play with stuff as much as we do. So that could be fun, just that. Making a cool column of layered stuff by itself is really fun for kids. They get to see the density. Now, we've talked about this a lot, but a thing that really helps in demonstrations or experiments for kids to become invested is for them to make predictions. So if I were you, I would ask them what they think is going to happen if you pour all these in. And this is where it gets customizable. So you can say, what do you think is going to happen if we pour all these in, and put them in the order of most dense to less dense. And then you can ask, what do you think is going to happen if we pour them in the opposite way? And let them see that if you want. You can ask them, what do you think is going to happen if we mix it all up, and then try it out. But the important thing is to ask them, what do you think is going to happen?
Yeah.
That's a great way to get them invested. And you can let them say, do you want to mix it all up and see if maybe they have that idea? What happens if you mix these up? But I'm kind of glad, Jam, that you switched the order around, because what that shows you is density remains the same between water and vegetable oil. The water will go down. But the dish soap is the emulsifier. We learned about how soap can bring oil and water together. So you saw a little bit of that probably.
Yeah, I did. Yeah.
So there are some things that can happen, some chemical interactions that can happen if you mix everything all up. So that's why this experiment is pretty fun, and you can do a lot of stuff with it, even though it's very simple. And if you have older kids, maybe you can tell them, why don't you try to make this with as clean lines as possible? And they might have fun trying to make a really beautiful, tall, skinny something. If you have maybe a champagne glass or a really thin vase, it could look really pretty in that. You can see all the layers really well, and something like that that's tall and skinny.
Yeah, dang. That'd be cool. Yeah, that would definitely, I think some of those are pretty intuitive to us, but I did think, okay, you definitely told me this order on purpose, but off the top of my head, I'm not sure that I would know which one would be on top with, like, the alcohol, for instance. Like, haven't really mixed rubbing alcohol with stuff. So it was kind of unknown to me what it would do. I assumed from being last on the list that it might be the least dense of anything, but I didn't know that from experience. So that was kind of interesting.
And you can do other things for sure. You can ask kids, what do you think if you just mix the oil and water? What if we added dish soap? And then you'll see a nice emulsion just between those three things. You know, you can really, it doesn't matter what you have. You can do this with any amount of stuff you have on hand, or just one or two things. And you can also ask kids to find other liquids to mix in there. What do you think will happen if we add laundry detergent instead of dish soap? What do you think will happen if we add milk? You know, let them say, what if we try this? And go for it. That's fun for kids and important and good for them to wonder and try. And we want to encourage that natural curiosity.
It kind of reminded me of when I make some coffee for my wife. I like to have the milk and coffee. I like to put the milk in first and then the coffee. And it kind of looks cool. I mean, it actually looks cool either way, honestly. But if you just don't mix it and let it kind of be separate, it looks pretty cool. And if you froth milk, the froth will stay on top a lot of times.
Yeah.
Even if the rest of the milk starts to settle at the bottom. So it's just kind of
I love
fun.
that.
Yeah.
I love the look of a dark coffee mixing with milk. You know, sometimes they'll put that as cool pictures at coffee shops. I love that.
Yeah.
Okay. Then I asked you to do a second phase of this experiment. You can do what you want with this. You can stop at the first part and then save it for the next day. Experiment part 2 for tomorrow to kind of spread out the amount of time you get out of this. You can just do the next part with oil and water. I've seen that done before. You can use the whole column. You can do whatever you want with this. But will you talk about what you did next?
Yes. So I took something I could quickly find to drop in, were a somewhat long and a slightly heavier screw than some. And then I also grabbed the smallest paperclip I could find, thinking that maybe there'd be some difference with those two things. And I couldn't find you had suggested like maybe a marble or a thumbtack. Wasn't able to find things like that quickly. But when I dropped the screw in, it being pretty solid and heavy, it dropped down really quickly. And then once it hit the honey and probably like around the corn syrup and the honey area, it slowed down a lot. And then for the honey, it did sink all the way to the bottom, but it slowed down a ton. It was just like this, quickly moved through the first several layers and then slowed down a lot. And it kind of looked cool. Had a little trail behind it as it fell. And then the paperclip, similar deal, but it took a lot longer for it to get through that corn syrup and honey section. But ultimately did fall all the way through.
So I think that's a good example. Well, actually, I'll say that. Jam, did that seem familiar to you at all? That experiment?
Seem familiar.
You took general chemistry for non-majors at University of North Texas, and that is one of the experiments that we did in that class.
I don't know. I'm just kidding. I don't remember that one. I remember a few different ones that we did, but for some reason that one doesn't ring a bell for me. But it easily could have happened, obviously.
There's other things that come into play, but that experiment allows you to approximate the density of different objects. Obviously, we did an episode where we talked about how paper clips can sit on top of water due to surface tension and surface area and all of that. So there's other stuff at play, but that's a fun way to show kids the relative density of a solid object and liquids. And it's just fun for kids to drop stuff in. You can get them to put their little Lego figurines in there. You can get them to get their toys that are obviously safe to get wet. Don't put a plushed animal or anything in there. And let them guess which layer it's going to be in. If you want to let this experiment go longer, or if you have younger kids, it's easy to just do it with oil and water. And you can use a matchstick. That'll probably float up higher. Try to, on purpose, gather things that are lighter and things that are heavier that you know will sink versus float. And let them guess where it's going to end up and then drop it in there. And this provides hours of fun. Maybe at least an hour of fun. And I recommend either trying to put the heavier things in first that you suspect are going to be heavier. Because if you have something tall and skinny, they can kind of clash. Or if you're using a pickle jar or something that's wider, try to put them in at different areas of the jar. But you can even use something like a bottle cap and put it in upside down to where it'll fill up and sink, or right side up to where it'll maybe sit on top more, so that you have a lot of options for things you can do and play with and see what happens, and let your kids really wonder and try and be curious and make guesses, because that is encouraging that scientific mindset at a really young age to explore and make inferences and all that stuff. So I don't know if make inferences is right. To explore and make scientific hypotheses in a much more casual way.
Yeah.
That really is a good way to foster that sense of a scientific mind at a very young age. And I think this is a good experiment for a lot of different ages, maybe all the way up into high school.
Yeah.
Maybe some teenagers are too cool, but definitely you can adapt this for younger and older for sure.
Yeah.
So that's it. That's our household experiment for the week.
I think that was definitely fun. And it makes me curious to think about some other, like you're talking about, maybe thinking of some other different liquids and ones I might not really know if I know which one's more dense or less. You know what I mean? So,
Yeah.
Like
Well, that's really fun.
Like what if I got like a soda which does have like corn syrup in it and something else? Like I wonder what happened there.
And it's bubbly.
And it's bubbly.
So does that impact the density overall?
Who knows what could happen?
You could do a flat soda and a bubbly soda.
Ah. Interesting.
See?
Yeah.
There you go. You're getting that wondering going. That's good for you. It's good for all ages, even grown-ups. Well, thanks for coming and doing that experiment, Jam. I always really enjoy these and enjoy imagining and hearing from people who talk about their kids doing the experiments. So let us know if you do them and what your kids think.
Absolutely. Thanks for teaching us. And guys, if you haven't seen the video of me trying this out, you can check it out on our Instagram, Facebook, or Twitter and follow along while you do your own experiment. This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. And we'd like to give a special thanks to E. Robinson, who reviewed this episode.